How's it going, guys? In this video we're going to continue on with the thermochemistry series. We have enthalpies of formation next, and we're just going to do a couple of problems. I think these ones are pretty straightforward. Basically, here is the formula that we're going to be using. It seems kind of confusing at first. So the delta H for the reaction is equivalent to the sum of the delta H of the products minus the sum of the delta H of the reactants. So that's not the best way to probably phrase it, but we're going to use this formula, and like I said, these are pretty straightforward, but I'm kind of going to go through it for completeness. Here we go. So the first problem, calculate delta H for, say, NH3 plus HCl yields NH4Cl, and given the heat of the delta H formation and the enthalpy of formation, in kilojoules per mole for each of these is going to be listed below in most cases. So NH3 is going to be negative 66.3. These can kind of be arbitrary numbers, but it's just good to throw something in to try to see if you can solve it. And then NH4Cl is going to be equal to negative 288.2. So basically, like I said, we're just going to throw all these into this formula here. This was the first time I ever saw that sign, but I think once you get used to it, it's not too crazy. For the first one, I'll write out the formula. HF products minus summation of reactants. And now we'll just move those in. Okay, so the enthalpy of formation is going to be 1 mole of NH4Cl times its molar mass. Oh, I'm sorry, times this right here is going to be 288.2 per 1 mole. And we're using these because of the molar ratio. So we're assuming each of these is just 1, so that's going to make it nice and easy for us. Also, we're starting with the products, so we're going to start with the NH4. And that is going to be, I like to double bracket because it will make sense when there's multiple on each side, minus this, which is going to be, okay, now we're going to go into our reactants, so each of these. So we're going to have the 1 mole of NH3 minus 66.3 per 1 mole, and because this is a summation, it's everything added on that side. So we're adding the reactants, and then we're subtracting the reactants from the product summation. So now we have 1 mole of H3, now we have the HCl, and HCl was the negative 104.7 per 1 mole. And then we'll just do this math out. So we have, again, this is going to be really simple on this side. Basically we have just negative 63 and negative 104. So we're going to have a total of negative 171 on this side. And negative 171 is being subtracted from what we have here, which is just going to be negative 288.2, and we should probably use the units, kilojoules per mole. kilojoules per mole. So we're going to have negative 288.2 minus a 171 negative equals 117.2, because this basically turns into an addition. Equals 117.2 kilojoules, negative 117. And again, that's exothermic. It's just good whenever you're in thermochemistry, I think, to every time you see the negatives, you know, figure out it's exothermic. Just because I think that that's an easy one, an easy add-on question that can sometimes get you an extra point or something. Okay, so here we go. We'll do the next one here. Calculate delta H for AgNO3 plus HCl yields AgCl plus HNO3. And we'll just break this down. So, oops, okay. The enthalpy of formation, and we'll have kilojoules per mole over here. AgNO3 is equal to, we'll go positive this time, 64.7. HCl is going to be equal to 29.3. AgCl is going to equal negative 104.4. And then HNO3 is going to equal, sorry, that's getting messy. HNO3 is going to equal negative 11.2. So we'll just plug this into this formula here. And I'm kind of simplifying this just a little bit, but products minus H of reactants. Now we'll just throw it in. Delta H of the reaction, the enthalpy of formation is going to equal, again, I like to just kind of do the brackets when I can. This time we're going to have two reactants and two products. So we'll start with the product side. The AgCl, we're going to have 1 mole AgCl is the negative 104.4, and that's 1 mole plus our other product, which is the HNO3, 1 mole HNO3. HNO3 is going to be negative 11.2, 1 mole. So all that minus we'll do, so now we have, let's see if I can squeeze it in. We have the 1 mole of, now we're going to do our reactants, AgNO3. $64.7. All right, I'm really a dreamer. 1 mole of HCl, I'll just continue it down here, times 29.3 kilojoules per mole, bracket. All right, so that wouldn't exactly go as planned, but here we go. We're just gonna solve this out. Luckily we have, again, a lot of ones, so we can just kind of throw things together. We have negative 104.4 plus negative 11.2 and 15.6 kilojoules minus this over here, which is 64.7. And again, we check the molar ratios, but we don't have any 2, so we don't have to really worry. Plus 29.3 is 94. And we'll just do that out. 115.6 minus 94. We're going to get 209.6 kilojoules, and that's going to be exothermic. Okay, so we'll just do one more. So the first thing you probably notice is this one has some actual mole ratios. And that's honestly as confusing as I'm pretty sure these can get. If there's like, a 6 and a 3 or something like that, that would probably make it just a little bit harder. But, as long as you're comfortable in algebra, you should be okay. So these enthalpies of formation are going to be NaBr 154.0. We'll have BaCl 2 67.1. NaCl is going to be 402.5, and then we'll have the BaBr. It's going to be 224.2. So this is probably a good time if you want to pause and then just try this problem out, and then you can compare with the answer that I get. I am not going to write out the formula for a third time. I think it eventually becomes unnecessary, but I'll just do it this way. So we're going to do, probably should have started a little further back. Okay, so 2 moles of times 402.5, and this is our NaCl. Plus 1 mole BaBr2. Nope, that's just BaBr, which is 224.2 kilojoules. And that minus what is going to be our reactants. So first we have the NaBr, which is 2 moles. And that's going to be times NaBr is the 154. And then we have plus, it's going to be 1 mole of the BaCl2. And I apologize, it's starting to get really messy, but I'm sure by the third problem you're probably pretty confident on these. 67.1 over 1. And now we'll just do out the math. So 2 times 405. Okay. Minus, and then we just have the 2 times 154. We have 375.1 kilojoules. Okay, so we have 805. All right, so we're gonna get 654.1 kilojoules. And finally, is it endothermic or exothermic? is going to be endothermic. All right, cool. So yeah, I think enthalpies of formation really aren't that bad. Hopefully I'm not insulting anyone by saying that. Basically, you just follow that formula, and it is a complicated formula, but once you get it down, you know, I think that you're pretty much good to go with these. And yep, in the next video, I'm going to go over bond enthalpies, and that will be the last of the 4 ways to find delta H. Hopefully this helps someone.